So this is chapter 10, section 2, simplifying radicals. Our learning objective is to simplify radicals involving products, which is multiplication, and quotients, which is division. So we're going to be using some verbiage. So to define radical expression, it's an expression that contains a radical, which in human terms is like a square root or a cubed root or etc. Anywhere in the roots range. All right. We're going to be asking you to simplify radicals. So I thought it was important to write this sentence down. A radical expression is simplified if the following statements are true. The radicand, which is what's inside, has no perfect square factors other than 1. So if you have a factor that's a perfect square, then you got to take it out. You also want to look for the radicand contains no fractions. No radicals appear in the denominator of a fraction. So when it says simplify, at the end of the day, you want to make sure you don't have any perfect square factors. You want to make sure that the radicand contains no fractions and that no radicals are in the denominator. When that happens, you know you are truly simplified. There's a little property of radicals that says if you have two items underneath the square root being multiplied, you can write them underneath the square root individually being multiplied. So I wanted to show you guys how that works with 48. So 48 is, if I'm listing the factors of 48, it's 48 times 1, 24 times 2, 12 times 4? 12 and 4. There is, let's do 12 and 4 since it seems the easiest. It's also 16 and 3, but that one isn't as evident. Okay, so work with me here. Do we agree that 48 is the same as 12 times 4? I'm not doing any crazy math. There's no tricks up my sleeves. 48 is 12 times 4. And if we use the same rule, here we can take the 12 and the 4 and split it up. So I can have the square root of 12 and the square root of 4. Do I know what the square root of 4 is? Yes. That's a crazy number called 2. Can I rewrite 12 as 4 times 3? So, and then can I apply this same property to 12? 12 is 4 times 3. Square root of 4 times 3 is the square root of 4 times the square root of 3. We know that the square root of 4 is 2. So let's shuffle this stuff around so that my 2 times 2 are right next to each other and my square root is second. So now I have 4 times the square root of 3 is the simplified form of 40. So let's try it with the square root of 72. We're going to simplify 72, and I know that 72 is 8 times 9. So that's the square root of 8 times the square root of 9. And that is the square root of 8 is the same as 4 times 2. And the square root of 9 is 3. So now we're going to do one more layer. This is the square root of 4 times the square root of 2 times the number 3. We know what the square root of 4 is. It is 2 times root 2 times 3. Let's shuffle these around so that's 2 times 3, which is 6 root 2. Make sure you want to write your radicals second and your numbers first. All right, so let's take it down to something a little bit more complex. So what if I have a variable instead of just a number? So I want to talk a little bit about what happens and how to deal with variables inside of square roots. One property that we're going to be using a lot is a variable with an even exponent is a perfect square. And a variable with an odd exponent can be written as a variable with an even exponent times a single variable. For instance, square root of n to the third power, I can write it as the square root of n squared times n. So you can take pieces away so that you can simplify individual pieces. All right, so we're going to apply that here. We're going to go negative m times the square root, 80m to the 9th power. So let's deal with the 80 firstly. The 80, 16 times 5. So square root of 16 times 5. And then how am I going to split up the m to the 9th power? I want an even power, so let's bump it down 1 to m to the 8th, and then an m to the 1. So I split up 80 to 16 times 5, and I'm splitting up the m to the 9th as m to the 8th times m. Okay, and then I have this negative m out front. Awesome, we got a lot of stuff going on here. So let's split it up. I got negative m out front. I got square root of 16, square root of 5, square root of m8, and square root of m. Let's simplify that down. Need a little more space. Let's simplify that down. I got negative m, he's still there. The square root of 16 is 4. Square root of 5, 5 is not a perfect square, so it just stays the square root of 5. Square root of m to the 8th, cut the 8 in half. M to the 4, and the square root of m is just the square root of m. Okay, now I'm going to shuffle everything together. So I have an m here and an m here. I'm leaving the square root m by itself because, sadly enough, he's a square root m. So that would be m to the 5th. And I'm going to rewrite my negative 4 out front. And I'm going to put these guys back together again underneath the square root. So your total answer after you shuffle everything around is negative 4 m to the 5th times the square root of 5m. All right, so let's simplify a couple of these. Now I'm multiplying these crazy things together. So let's simplify and see where it gets us. So I have, when you have two radicals being multiplied together, you can write them as being multiplied under the same radical. 6 times 18. 48. 108. So this is 3 times the square root of 108. 108, because I'm a math nerd, I know that's 12 times 9. It's 108. If you don't know factors or whatever, you can work factors on the side of your paper with a calculator. Please don't feel like you have to be like me. So I know that 108 is 9 times 12. And the reason I picked that is because 9's a perfect square. I love perfect squares. So can I rewrite 12 as, what two factors give me 12? The one that has a perfect square. Yeah, 3 and 4. Okay, so we got 3 times the square root of, let's see if I can write a number 3. Square root of 9, square root of 3, square root of 4. These two guys are perfect squares. They're going to combine with my 3, and my root 3 is just going to stay. So then I have 3 times 3 from the square root of 9 times 2 from the square root of 4. 3 times 3 is 9. 9 times 2 is 18. Root 3. All right, so let's take a look at B and see where we can go from here. Let's put it all underneath their radical. So I got 2, I got 9, I got A, and I got A to the third. I'm happy that this could be square root of 9, 2 square root of 9, but I'm going to combine these two together to give us A to the fourth. And so for my answer, I get square root of 9 is 3. A to the fourth, because remember, even power is a perfect square, so we cut that power in half. A squared. And then root 2 hangs on. Alright, so let's see if we can put this together. A door's height is 4 times its width. Let's draw a picture. Door is a rectangle. Its height is 4 times its width. What is the maximum length of a painting that fits through the door? I guess if we turn the painting sideways. So for any of you guys who have ever moved furniture through doorways, you know that the best way to arrange a picture is diagonally. So we're going to fit this painting in diagonally. So they actually want us to find what is the maximum length of a painting. We're going to assume that our door is a right angle, and now we got Pythagorean theorem rolling around with us. So we know that the length of our painting squared is equal to a squared plus b squared. So this is a, b, and c. And a squared plus b squared plus c squared. So we are going to L squared and W squared, nothing to simplify here. This square is going to apply both to the 4 to give us 16 and both to the W to give us W squared. The length squared is equal to, this is 1W squared plus 16W squared gives us 17W squared. And the maximum length is what I get when I take the square root of both sides. So in this case I get square root of 17W squared. We know that's equal to 17 under the square root, W squared under the square root, and at the end of the day it's the square root of 17 times W. Okay, so just like multiplication, when we divide or write as a fraction underneath the square root, we can take each of those individual components and square root the top and square root the bottom. We don't have to keep them together. For example, square root of 36 over 49 is equal to square root of 36 over the square root of 49, which is equal to 6/7. So we're going to do that with each of these. So the first one, the square root of 144 over 9 is the square root of 144 over square root of 9. That's equal to 12 over 3, and oh yeah, I know that's 4. Can't fool me. So in this scenario here, this is the square root of 36. Let's take care of the A's first. 1A here cancels one of those here, and I just have a to the squared. A to the squared. A squared. Then I split up the radicals, and I have square root of 36 is 6. Square root of 4 is 2. Square root of a squared is a. Then I know 6 over 2 is 3. And a's on the bottom. One more. Let's split this up. Square root of 25y to the third over square root of z squared. Thank goodness I know I can go square root of 25 times square root of y to the third. Square root of z squared. That reduces down. Square root of 25 is 5. Y to the third is y squared times y. So that's the square root of y squared times the square root of y. Square root of y squared is y. And square root of y, square root of y, so I just rewrite it. And then I have z on the bottom. All right, you're going to be asked to rationalize the denominator. which means we want to remove the radical from the denominator. That may include multiplying by the same radical expression on the top and bottom. So remove the radical from the denominator, and we may have to multiply by the same radical expression on the top and the bottom. Many moons ago, before you were even a thought on this universe, mathematicians got together and decided we need to rationalize denominators. Can't have square roots or any roots in the denominator. It's just not allowed. I'm not going to lie to you and say that there's a rational reason now. We don't use slide rules anymore. We have calculators. It's okay to divide by a radical then. We do this for the mere purpose of showing our math grades. Alright, so when you get a problem with a radical in the denominator, all we have to do is multiply by that denominator radical and look at what happens. So we get the square root of 2 times 3 and the square root of 3 times 3. Square root of 2 times 3 is 6 and the square root of 3 times 3 is 9. And oh yeah, heck yeah, we get the square root of 6 over 3. No more radical in the denominator. We can do the same thing here. So we're going to multiply by root 18m, root 18m. And we get roots 5 times 18 is 90m over 18m times 18m. 90 is 9 times 10. (18m) times 18m. I'm pretty sure that's 18 squared times m squared. Square root of 18 squared is 18. Square root of m squared is m. Square root of 9 is 3. And then 10m is here. 3 goes into 18 6 times. 3 goes into 3 1 time. Square root of 10m over 6m.